Today's episode is a long one, over an hour of VR and how to create it with Jim Malcolm. So hang in with me and let's do this. You are listening to the How to Create VR podcast, weekly conversations with VR professional creators, designers, and producers. Today, my guest is Jim Malcolm, an industry expert with more than 2 decades of imaging, virtual reality, and consumer product experience. Jim was the president and chief marketing officer of Ricoh Imaging. Today, he is the general manager of Humaneyes Technology. Jim, welcome to the podcast.
Hey, thank you. And it's nice to be here.
I heard a great interview with you on the way to the office. It was on the Everything VR and AR podcast, which, by the way, I recommend people listen to if you're into VR and AR. And I told myself I got to have Jim here just to set us straight about VR and specifically VR content creation, which we're going to get into today.
Well, I'm glad you're able to find that. And, that was particular interview was pretty fun for me because it just kind of came together, and you kind of get this good routine going sometimes, and they just feel good. That one felt good.
It was a chock full of information, so I highly recommend everybody to search for that. It's the Everything VR and AR podcast, so shout out to them. And today we're going to talk about just general content, creating VR content. How do you get into it? All that kind of stuff. But before we do that, you were the president of Ricoh, which is one of my favorite cameras also, is the Ricoh Theta S. Then I just upgraded to the Theta 5. Yep. So you oversaw that, right? Tell us a little bit about that.
I did. I joined Ricoh a while before that, back when we acquired a camera company called Pentax. And as I joined, I was actually bringing with me a bunch of experience I had from earlier in my career where I worked for Sony Electronics for a really good chunk and launched the world into digital photography. And then I did a startup called Aperture 360 Interactive, which specialized in 360-degree imaging. And back then, we took pictures, we took about 17 pictures and stitched them all together to make a single still image that was 360 degrees. So I joined Ricoh and not only did the acquisition of Pentax, but in parallel worked with them to develop a spherical camera that could capture a full 360-degree world in a single exposure. And that product came to the market as the Ricoh Theta, then became the Theta S, and as you said now, Theta 5.
And it's one of the most popular consumer-grade cameras out there because it's so inexpensive and very small form factor too.
Yeah, and what's interesting about it is because of the type of an optical path that we used in developing that product, there's really almost no parallax or shift between the two lenses. And as a result of that, there is very little stitch error that you have to correct for. In fact, the camera really doesn't technically stitch like we think of stitching out of other camera systems.
Oh, that's interesting. Can you expand a little on that? What you mean by that?
Well, first of all, I'll say the reason that the images that both cameras on that camera system see the same field of view is because unlike other camera systems where the sensors are back to back, so you look at something like the Gear VR, the camera is a little bit thicker, right? It's a ball and it's a little bit thicker, so the lenses are further apart. And that's because the sensors are actually back to back. On the Theta, both of those lenses come into a prism, which is in the middle of the camera and splits to the left and the right of the camera. So the sensors are actually on the sides of the camera, not directly behind the lenses. And as a result, that's why that camera system is so flat. And by making it so flat and sharing the same, not to get too technical, but the same rear nodal point of the lens, you can overlay the left and right image, and basically they are seeing the same thing. So blending those together is really easy.
Now, there is one little thing with the Theta 5. There's this red dot, depending if the sunlight is hitting it. Is that because of the prism, the way that works with the sensor?
Sort of. It's not just the prism, but there's optical properties that we have to deal with and chromatic aberrations. And when you get pinpoint light going through really any lens, and especially a really big fisheye, right? That's a 200-degree field of view lens.
Right.
You're going to get a hot spot, and it's just basically bleaching, if you will, the sensor. But it bounces in the lens, so it's not exactly where the sun's coming in. It's adjacent to that on another point of the lens. Basically, it's a sun flare within the optical system.
Right.
And you can't really put a lens hood on like it's what you would do in traditional photography to block that out. Because if you did that, you would block part of your image.
Right. There is no frame in 360. Everything is in the frame.
That's right.
So, that makes a lot of sense. But we're not going to get more into Ricoh since you already left. And how many years ago did you leave?
About a year and a half. When I left Ricoh, I started a company called Zyality. and Xiality is focused on the distribution of VR content. And through that process of trying to distribute VR content, I came into all kinds of different hurdles and really started doing a lot of study of what VR content is all about. And the one thing that rang true to me was stereoscopic 3D, that without stereoscopic imagery, VR, not to sound cliche, comes out flat. So I started doing a lot of research on companies that had leading intellectual property on 360 3D, and Humaneyes came to the surface. And I made the decision to join them because I really believe that their core competency, or I should say our core competency now, is driving that VR video component.
You say 3D, and I didn't understand fully 3D until, again, I heard this podcast with you. And it makes sense, right? Because 3D adds depth that you don't have in a standard 360 video if you want to actually embed it within the VR world.
So if you take something like, well, we talked about Theta, let's pick on somebody else for a minute. Let's either talk about...
the GoPro Fusion.
There you go, GoPro Fusion. 360-degree camera, high resolution, great. But when you put it in a VR headset, you're basically showing the same image in both the left and the right eye, right? So in a VR headset, you need to have a left and a right eye in order to see what's going on. And if you project the same image, it becomes monoscopic. It's kind of like you're kind of looking with just one eye, but it's really two eyes, and everything looks flat. And I wish I had a more technical term other than saying uncomfortable, but it is very uncomfortable to look at this image that's been wrapped around your head that's flat. So it's really not believable and it's not comfortable. And so in order for something to be believable, for our brain to go, oh yeah, I get it, you need the depth cues. So depth perception makes a difference as far as the level of immersion that you can deliver. That level of immersion gives you comfort, and comfort gives you the willingness to stay in that headset longer.
And that's where 3D comes in.
That's right. So 3D is both left and right eye images. It can't be the same image in each eye. It has to be two separate images captured from two different points of view in order to give you that depth perception.
Before we move forward, explain parallax, because that is a big part of 3D, right?
It is really the driver. So when you think in terms of both a left and a right eye, hold your finger in front of you and you close your whatever your dominant eye is, leave it open, right? So in my case, I'm left eye dominant. So if I close my right eye and look at the tip of my finger and align it with something in the distance, and then I switch eyes, it looks like my finger shifts, right? It moves off of that point. And it's that difference between the left eye and the right eye that the human brain uses to determine how far something is away. And our body is really good at deciding distance for things that are relatively close. So within that, call it 0 to 2 meters out, right? 6 feet. We can really see clearly depth. Then from 2 meters to 15 meters, or call it 6 feet to 45-ish feet, we still get a very, very healthy 3D effect. We can see a lot of spatial representation very easily. Beyond 45 feet, the human eye kind of compresses everything anyway, so things kind of look flat at distance. And so when we think about the benefit of parallax in our vision, we know that things that are up close, we can tell relative distance much more than we can tell relative distance of things that are at the distance.
And that's what gives it more of a realistic, immersive experience, and also a more comfortable one, because we're used to seeing that in real life.
Absolutely. That's exactly right.
Right. As opposed to just a standard 360 video, which is just flat.
Yeah, it just looks like one flat field. And the way I try to explain it to people who haven't seen it is, if you imagine just wrapping a poster around your head and then looking at the poster in all directions, that's what 2D video looks like in a VR headset.
Yep. You're inside the sphere, looking up, down, all around, but that's it. There's no depth.
That's right.
Yep. So let's set sort of a baseline here. There is AR, VR, MR, 3D, and who knows what's going to come out next week. Real quickly, the differences between them.
Okay, first I'm going to give you my disclaimer that everybody's definition changes slightly, so please do not, if I say something that you don't agree with, let me know, but don't throw rocks, because we all have our own thoughts.
Of course.
So VR, virtual reality, is probably the most commonly used term, and I consider that as any world or any environment that has been created to represent another place that you can put into a headset and you can look at it in the VR environment. It might be computer generated, it could be photorealistic, be a bunch of different things. But it is a field of view that you can look around, see everything around you, and in some cases even interact with it. So that's what VR is. AR and MR become the two next most difficult ones, and this is where some of the controversy may come in. AR, or augmented reality, the way I define that is digital data that is overlaid on top of the real world. So for example, if I hold up my mobile phone and I look at the front of a restaurant and the system determines, I'm looking at this particular restaurant and the menu pops up so I can see what's on special tonight. This is augmented reality, where I'm taking the real world in real time and overlaying data with it. It gets a little bit different when you start thinking about MR, or mixed reality, because mixed reality is also combining digital information together with the real world. So the way I like to define that one in my mind is mixed reality is when you anchor or attach an item to a specific piece of the world that you're looking at through your mobile phone or through a headset that has pass-through optics on it. So for example, if I take my phone and I hold it over the kitchen table and I can see the Monopoly board game, and all of us are playing Monopoly on our phone on our kitchen table. Now, of course, the board is not really on the kitchen table, but if I move my phone around, that board stays stationary on the kitchen table. That's what I consider mixed reality, because you're anchoring digital data into a real world environment, not floating it over.
And I think a good example of that is Snapchat, I think. Now, I don't use it, but I know there's filters that you can attach stuff to your head, and that would be more of a mixed reality that you're talking about. It's attached to you, and when you move, it moves.
That's how I look at it. Now, people have other points of view on that, but hey.
Sure. Well, we're asking you. We're not asking them.
There you go. Perfect. 3D, we've kind of covered that road on the 3D side of things. So we got AR, VR, MR, 3D, and then there's two other terms I'll throw in there. One is 360 video, and the other one I'm going to say is VR video, because I think they're two very distinctly different things. 360 video is a video that allows the viewer to look around in any direction and to be able to make decisions on what they're looking at in real time while that video is playing back. The proper use for 360 video is to play it back on your computer screen or your mobile phone or tablet using your finger to drag around, right? So that's 360 video. VR video is something that is captured with both a left eye and a right eye parallax that is purposely designed for playback in a VR headset that delivers not only 360-degree video, but 3D video, as well as first-order ambisonics, so that you have a matching audio field together with a video field in full immersive video.
And this is the connection with your current company, right? This is what you guys are doing right now.
That's correct.
More of the VR video. So let's talk a little bit about the VUZE camera, which is what you guys are putting out there, that has the ambisonic audio, 3D. And then let's define also ambisonic audio. And is there any other type of surround type audio?
Okay. So
I know it's a lot of stuff.
I know. And you know what? If I was a creator out there and trying to get my head around everything that's happening in the market right now, sometimes it can make your head kind of start to feel like it's going to pop off.
But at the same time, as a creator myself, I find it that we're at a frontier here and we're at the beginning of something amazing. And all this stuff is so cool that my head is going to explode, but in a good way.
Absolutely. And if you want to add one more layer to that, I'm going to give you my analogy on the screens for a minute. So we have TV screens in our lives, right? People still watch TV. Maybe it's not by appointment. Maybe it's streaming TV shows or what have you. But TV is still a big component in our lives. The mobile phone is also a major stream of communication in our life. We have our computer screen on our desk. And there's also what I refer to as the fourth screen, which is the VR headset. And if you think of the VR headset as a screen, then you're going to have specific tools to create for that screen. Just as I would use certain equipment when I produce something for TV, or I may choose something different when I produce for my mobile phone or my mobile devices. When I develop both stories as well as hardware requirements for creation of a VR headset, there are certain things that I would consider when I make that. So what the VUZE camera does is it creates content for that fourth screen or for VR headsets. Let's just start by saying it's an $800 camera. So it's not like you're breaking the bank with some of the $25,000 plus solutions that are out there. The VUZE camera is based on 8 full HD cameras. We use 4 of those cameras to create a 4K video for your left eye. We use the other 4 lenses to create a 4K video for your right eye. Each of those videos are spatially offset the width of the human eyes, the same way that the phone has spatial offset when it's put into a VR headset, or if you buy a straight up VR headset, they have the spatial offset. So basically what we're doing is we're reproducing what the human eye can see as close to perfect as we can, so that when you play it back into a VR headset, you have proper, true 3D fields in all directions stitched together to make a seamless world.
And you said it's 4K. So can we explain the difference between a 4K sphere and the viewport of what people see? Because sometimes people get confused when they think of 4K or even 8K, a 360 video camera. They go like, well, it doesn't look like the 4K that I'm used to seeing.
Part of the reason that they're not seeing what they're used to seeing is because of the resolution of the headset. So it's easy to look at it and say, well, there's just not enough resolution for it to look good. The truth is that there really is enough resolution there for it to look good. The problem is that the headsets can't deliver the data. That's one answer. Let me give you another answer, which is if you think about a 4K world, and let's say I output my file as 3840 by 2160, which is what's called UHD, or broadcast 4K video. And I have a headset that allows me to see 90-degree field of view at a time. In other words, when I put on that headset, I'm looking in a direction and I can see about 90 degrees of that total 360-degree sphere. What I'm really looking at is about 1,000 pixels, or if you get really technical, you're looking at about 960 pixels when you're looking in that direction. You're not looking at that 4 full K field in your field of view. You're looking at about 1,000 pixels in that field of view. 1,000 pixels is enough to get a good quality video. The problem is that the VR headsets, that resolution of the headset, you are actually looking at the distance between your pixels, the spatial distance between your pixels, that make it look pixelated, as opposed to the picture data falling apart from the amount of data that's in the digital file. I think I've done a terrible job of explaining that, so ask me your questions and I'll try to fix it.
No, it makes sense. And one thing I want to clarify too is that some people, probably most people nowadays, that they don't have the head-mounted displays, the HMDs. They're watching this video, which they thought was 4K, on their 4K monitor or 3K monitor in full screen. But they're only seeing, like you said, the 1,000 pixels because that's the viewport that they get to see, unless they spin things around. But they're always looking at 960 pixels. And I think that's where possibly people start saying, well, I thought it was 4K, but it's a 4K world.
Okay, so that's a very good point to dig in a little bit deeper on, because the VR content that's created with our camera, in fact, with many cameras in the market, is output in a method that is intended to be played back in a VR headset. And when you put it in a 2D world and you blow it up to the size of the screen, yes, you are going to see the file start to break down, because it's really not intended to be full screen on your screen. And if you think about the viewing distance of your screen, the intent of that screen, so let's take, for example, an Apple iPhone with a Retina display. All TV screens and mobile phones and computer screens, the scientific definition of the resolution or the proper viewing distance of that is 3 times the diagonal. So your mobile phone, let's say you have a diagonal measurement of 5 inches on your phone. It's really intended then to be viewed at 15 inches from your face. So if I have a billboard that's 20 feet wide, it's really intended for me to look at it from 60 feet away, 3 times that diagonal. And if I got any closer than 3 times that diagonal, closer than 60 feet, the billboard's going to start to look like it breaks down, like you're going to see all of the pixels that are printed, or the big print marks. And that's same with things like the Jumbotron you see at the football stadium and everything else. So this idea of 3 times the diagonal makes a lot of sense until you take that phone and you place it, or whatever headset it is, right? And you place it 2¼ inches away from your eyeballs.
And it would be the same as being next to the billboard.
Exactly. And so what you're actually looking at when you see all that pixelization in these headsets, is you're actually looking at the pixel structure of the display. We call it the screen door effect, where it looks like you're looking through a screen door. What you're actually seeing is the separation between the pixels. Any of your listeners can do a little experiment, grab a decent magnifying glass and pick up your phone and look at it with a magnifying glass. You'll see all of those little marks that are in your phone. Those are the same things that are being magnified when you put your phone in a VR headset. And if you look at the headset, it's got little magnifying glasses that magnify against your eyes. And again, I keep saying put your phone in there, but the regular VR headsets that have embedded like an HTC Vive, they have the same issue, right? The screens are embedded in there. The principle's the same. They're just not removable.
Right, right. Well, the other part that I think affects the video quality or the quality that you see in your HMD is the glass itself. Maybe you can touch a little bit upon that, right? Because you can have 4K resolution per eye, but if that glass is not a good glass that's in between your eye and that display monitor, you're going to have issues.
That's right. In fact, I'll point to a recent issue that I just started to have because I started playing with the new Microsoft MR headsets. And so far I've played with 3 of them. And the way that 2 of the 3 are built, they have Fresnel lenses. And so the Fresnel lenses is kind of it's a round circular pattern on the lens that's in front of the sensor that helps focus the light and helps you to be able to see things, right?
And my filmmaking listeners will know about that because that's what's used for lighting as well.
Exactly. So that lens technology, if it's molded in plastic, which most of these are, right, it's going to give you a certain optical property. And then the actual placement of that directly in front of your lens becomes very critical. Because if your eye is too high or too low or a little left, a little right, you're going to start to see the curvatures of those lenses and it's going to drop off and be out of focus. So for me personally, I've had a lot of trouble with 2 of the new MR headsets because either my eyes are too close together or the placement of what's called the IPD, right? The interpupil distance is too wide on those headsets. And I have a very, very hard time keeping anything in focus. There is one exception so far, which is the Samsung branded Microsoft VR headset. And that one actually has a mechanically adjustable IPD or interpupil distance. So I can line those up directly with my eyes. It's got a much better lens structure on it. And so far for me, that headset's working really well.
Yeah, I think the Oculus Rift also has one.
Yes, it does.
At the bottom right that you can adjust. Although I keep adjusting it and I still feel sometimes that I have to wash my eyes because it looks a little cloudy at times. So it's still not perfected, obviously.
Yeah, it's not. And then you look at somebody like, I think somebody who's done it really well is Zeiss. I mean, Zeiss is obviously very good about making optics right anyway, but they have a product called the VR1 Plus. And they use glass optics in their headset, which is fantastic. But the aperture is kind of more like an oval or an egg-shaped aperture in those headsets. So even though there is not an adjustable IPD, the width of the viewing area on those headsets is wide enough that it can accommodate a very wide variety of pupil distances and still maintain outstanding image quality.
So as we can see, there's a lot that can affect the experience for a user, but a big portion of it is motion. And today we don't have that, right? You put on your HMD and you don't have motion. You may be moving within the virtual world, but you don't feel it. And that's where we start getting sick as well, right? When things in the virtual world are moving, but we're standing still. So as creators, where do you see that going? What can we do to sort of bring that motion into the experience?
Yeah, it's probably one of the most misunderstood pieces, especially from people who are coming off of 2D 360 cameras, because they are used to maybe mounting the camera onto, I don't know, a jet ski and running around or something like this. And then you put it in a headset. And to your point, when you interject motion, whether it's the camera moving or quite frankly, even subjects moving around you, you can make people feel sick really quick. There's some basic principles that can be used. One is just the basic, right? Least common denominator is really control how you move the camera and avoid things like rotating the camera left and right. Because if I'm moving the camera, say I move it forward and then I twist you to the left or right, like force somebody to look in a certain direction, this is not natural for us to do. We're not used to somebody grabbing our head and saying, hey, look over here, look over there. We want to use other storytelling techniques, whether it's graphics or sound or action, that draws you to areas of the frame that you want to look at, as opposed to directing them by moving their head around, so to speak. So that's one way to do it. But I've also seen some really good use of motion in VR, particularly when it's used in the case of, we'll refer to the cockpit effect. So let's just say we're going to take a ride through Malibu in California, right? Early on, I saw people, in fact, I still see people today, taking a suction cup and putting the camera on the hood of the car and driving through Malibu, right? Okay, an interesting perspective, a nice tour, but not what a viewer is used to seeing. The better use that I've seen is where somebody takes that camera, puts it in the passenger seat of a convertible, right? Uses some sandbags and props it up. And then when you put your headset on, you are sitting in the passenger seat of the car. You have the cockpit around you, the vehicle itself, that frames you and makes you feel anchored and safe, and then the world moves around you. So that type of a technique helps to eliminate motion sickness.
You know, one thing they're doing in video games, at least, is instead of having you move around by walking or running, you teleport to different places. So that helps in cutting down that motion sickness from a gaming perspective.
Yep. So teleporting certainly helps. The thing about walking, so I get a lot of people that think they want 6 degrees of freedom and they want to be able to walk around their living room and enjoy an experience. Even in the gaming world, right? You need to have boundaries. The HTC Vive calls it a chaperone, right? So it's basically the wall that you can, you're walking up against, and you're maybe dealing with a 5 foot by 5 foot area. So although you can stand and move and walk around, you're not really like walking. Although I did go to a great VR experience at MGM in Las Vegas last month, where you do walk around in a 2,000 square foot warehouse in virtual reality. And that was like really cool, wearing a backpack and everything. We could talk about that later.
I did one similar at Adobe Max, and I don't know if it was the same one, but they set it all up and it was a warehouse within Adobe Max, and you walked around with a backpack behind you, and it was crazy.
Yeah, it's great fun. And yes, that's all computer-generated worlds, and will someday you be able to walk through Versailles and take in the sights and sounds? Absolutely. Somebody will map it and turn it into a digital environment to be able to manage the traffic flow, for the lack of a better term, through the environment so you don't walk into each other. But that's big picture stuff, right? We got to figure out, how do I tell a story today? How do I entertain and educate and get people paying attention to this category as we build these much bigger and much more sophisticated models?
Well, you just said a couple of things that are super important. Number one is, how do we get people to pay attention to this? That's number one. And I have to tell you, just from my perspective, I was not a believer of VR just because I didn't get it. Then Black Friday came along literally a couple of months ago, or not even a couple of months ago. I bought my first HMD, and I'm a complete believer of this technology. So that's the first question, is how do we get, as content developers, people to adopt this? Because it's not an easy thing to adopt. It's not like you're turning on the computer or the laptop or the tablet and you're set. There's a lot of cables. There's a lot of stuff you have to do.
Yeah. Where to start on that one? The least common denominator to get started in any of this is a way to look at your mobile phone in 3D. Now, that could be something as simple as little Google glasses that you simply plug onto your phone, Google Cardboard, a headset you drop your phone into, all the way up to these dedicated headsets. And you have to start to experience what the potential of VR is. And that really requires us to spend a fair amount of time watching different types of content and judging it for not only the image quality, because if you look only at image quality today, because the headset is going to be the part of that puzzle that's going to disappoint you. But more importantly, you have to start to look at, what is the story being told? Where is the emotional median going to be able to be affected? And how do I start to express or engage somebody against a brand or against an experience or against an emotion in a headset? And so if you get that part of it down first, and it sounds like now that you have your headset, you're starting to experience more pieces, and it's starting to open up the curiosity to say, boy, I got to invest some of my time into figuring out more of this.
Right. And the possibilities of what we can do with this.
That's right. And I think it's the possibilities that are most misunderstood. So I was just in New York last week and put the headset on some folks. They'll name nameless, and they're like, this is ridiculous. Like, it's pixelated. It kind of looks fuzzy to me. I don't know. It's cool, but I don't get it. Right now, this is a 40-something person. I went over to their house for dinner, and they have 3 kids, and one of the neighbor kids was over. So I have 4 kids there. I said, hey, you want to see something in virtual reality? They said, sure. So I put a headset on them, and they went skydiving. They went down under the sea and went diving, like diving underwater. They went through a museum. They just looked at, just little clips. And when you watch people who are not judging the quality, but they're judging what they're looking at, or they allow their minds to just go and enjoy what they're looking at, it is so refreshing. It is so exciting to see what these minds, what they're thinking. They're sitting there and they're pretending like they're swimming, right? Here's a 6-year-old pretending like he's swimming at the table going, look at him down here. There's a turtle and I can see these fish and it honestly puts like chills up my spine. I'm like, yes, these kids get it. Now he's got to get us old folks to get it,
I'm totally with you. And by the way, old folks, I'm 50, so I know what you mean by old folks. But I think you're right. Some people are focusing so much on how it looks versus the actual experience and the possibilities of what you can do with that experience. I mean, I put on the headset and literally the room where I'm at in 5 minutes is gone. Psychologically, my mind tells me I am no longer here at home or in the office. I am wherever this experience took me. And I think you have to let go and just feel it. Otherwise, VR won't work for you.
That's exactly right. I bring it back in the old days. I'm not far from you age-wise. In fact, I have you beat. Well, at Sony, we launched a product called the FD Mavica. And this was a digital camera that took VGA resolution pictures on a floppy disk that you could then take the floppy disk out and put onto your computer, and you could view this VGA resolution image on a computer screen. If you can imagine photography without film. And I used to go into the photo retail stores and say, hey, look, we got this great technology. I can't tell you how many times I was laughed out of the store. And they're like, you know what? The image quality is terrible. Nobody wants to have to go out and buy floppy disks to look at their pictures. It's a fad. It's never going to take off. Get out of here. Well, we now know where digital imaging has ended up. It's the same thinking and it's the same excitement that I got back when I introduced digital cameras that I see in virtual reality. And it will not only transform how we live, but it's going to transform how we communicate. It's going to be how we interact. It's how we work. It's how we build. It's everything. All of us, even within my lifetime, we will live part of our life in a VR headset. And when I say that, I don't necessarily mean this big giant scuba mask that we wear today.
Right.
They're going to become higher resolution, lighter, better image quality, blah, blah, blah. But we're not there yet. We're still here.
Well, and I totally remember that camera because in 96, 95, 96, around that time period, I was working at NBC.com. Okay. This is when they first started, when there was .coms weren't around. It was just one of the first few ones. And we had one of those cameras that had a floppy disk, and it was the worst resolution ever. But like you, I saw the potential of where we're going. Film, in my mind at that time, was dead already.
Yep.
Because I saw where this thing was going. And I compare VR today with the internet when I got into it, which was literally in 94. You know, at the beginning, this was before Chrome. This was before Netscape. This is, way, way, way at the beginning. And I think this is where we're at today. I remember with my wife seeing a billboard that had the first .com on it. And I got so excited. I'm like, check it out. There's a website. They're advertising a website. And this is before website. I mean, today it's ridiculous. But seeing a .com on a billboard was like a huge thing back then. Yep. And I think VR today, we just went to the auto show this weekend and they were doing some AR stuff. One of the booths there. And I got all excited. And it just reminded me of that billboard. It's like, check it out. They're using AR and VR. And I think this is what we're at today. And that's why, for me, my mind explodes, not just with what's happening today, but what's going to happen in 10 years. It's going to blow our minds. I mean, to me, it's, the holodeck. I think it'll be in 10 years.
It will. Forget Moore's law for a second. We're going to exponentially see this growth curve come at us really quickly. And not only how we wear our headsets will change, but how they start to build in AI, right? Yet another term we didn't talk about, right? But artificial intelligence in order to alter our AR or VR experiences without our conscious interaction is one of the things that like really, really excites me. So to explain a little bit further, today, if let's say there are three cars in my VR headset that I'm looking at, right? There's I don't know, an Audi, a Lexus, and a Mercedes, right? Today I have to decide either by click or interaction of some sort to say, hey, I really want to go look at the Audi. And then specifically, I want to look at the R8, whatever, right? In the future, gaze detection and heat mapping and other technologies will come into place where I simply look at something and where I spend the majority of my time or however we script that to happen, right? I will be taken there without me having to actually give an interaction because subconsciously I will have told the experience that that's what I'm interested in. Give me more of that and less of these. And it's the more of that that's going to keep feeding more and more information.
Well, and what you said really reminds me of when you go shopping at Amazon and then you come back and all of a sudden it knows more of that I like and it starts telling me. So it's something similar to that, right?
It 100% is. But today in the Amazon's model, you've had to click or put into your shopping cart or search for, right? But now with AI, systems are getting smarter and smarter, and the predictive models are getting better and better, that we're not going to need the input. And even though today computers are not smarter than us as far as our decisions are concerned, and many will say, oh, it will never happen. I believe that it will happen. I believe that there is enough computing power out there and enough unused computer hours that when somebody who has large amounts of data starts pushing it out and crunching it and turning it into usable interactions, that it's going to blow our minds how we are living our lives in the future.
I agree completely. I think we're going to get to a point where we may not even know sometimes the difference between the VR world and the real world. And I know that opens up a whole philosophical question, which as a person interested in technology, I don't care about now, but I know a lot of people do. But it's going to be super interesting. And the possibilities, not just for all of us in that, but also for people, think of handicapped people that can't move. VR is going to be something that can help them.
Oh, absolutely. We're already seeing it today. I was out at an event and talked with some folks from USC who are doing amazing work around elder care and dementia and Alzheimer's patients, and giving them the opportunity to ride a bike through the streets that they grew up in to treat and remind them and to keep them engaged with their lives as they're aging and their memories are starting to go down. And there are huge therapeutic results being reported of VR.
Right. The possibilities are amazing. Jim, I have like 30 questions to ask you, and we got through 2 of them, I think.
Go ahead, ask me some more. Let's move on.
Let's talk about refresh rate. Why is refresh rate so important as a creator when you're creating VR?
Let's talk about both refresh rates, and we're also going to talk about frame rates for a minute because they're really addressed in 2 separate ways. So refresh rate, as I look at it, is how many frames per second the headset can refresh itself with a new image. Now, there's a lot of study that's been done around VR headsets that magic sweet spot is 90 frames per second. Anything less than 90 frames per second that are displayed in a headset, when you move your head, in fact, the faster you move your head, you can almost see a strobe effect or a refresh effect as you look at that screen. Most of the mobile phones, for example, you have today are only refreshing at 30 frames per second or 30 cycles per second. And so when you move your head, you see this kind of pulse or almost like a trailing effect that shows up in the headset. Now, if you move your head slowly, you're not going to see that. But if you move your head quickly, you're going to see it. So that's refresh rates. Now, there's also frame rates, and the frame rate is how many frames per second are used to capture the video that's played back in that headset. I can take 30 frames per second and play it back in something like an HTC Vive, where the computer simulates 90 frames per second, and I can get a fairly comfortable view, even though I'm kind of looking at repeated frames, right? So I'm looking at multiple frames in that headset, but it fills in the gaps. So there's ways to kind of cheat a slower capture frame rate and play it back at a higher refresh rate. But that being said, the kind of holy grail, if you will, out there capturing would be to capture 90 frames per second and play back at 90 frames per second. And this would eliminate any flicker that may happen when you're looking around.
Now, from my understanding, please correct me if I'm completely wrong, but the higher the refresh rate, the less potential for us to get sick. And that's why right now the current HMDs are 90 frames, right?
So the Oculus CV1 and the higher end Oculus pieces, as well as HTC Vive, they do play back at 90 frames per second. They do require a pretty robust computer to do that as well. So you may hear, for example, that Mac is not good at VR, and it's true. Sad, but true, because I'm a Macaholic. But because VR relies on the GPU of the computer, the graphic processing unit, it's there. You can take even a standard 4K video to turn that into 90 frames per second. You're dealing with a tremendous amount of data, and that's very computationally heavy. So you do need to have a pretty good GPU in order to feed that. All that being said, if I look at something like the Gear VR from Samsung, where I put my mobile phone in that device is simply playing back at 30 frames per second. So even though it's in a head-mounted display, I'm still only looking at 30 frames per second worth of content.
But as technology goes, I mean, GTX 1080 is going to drop in price, I'm sure, in a couple of years. And the power, it'll come, right?
It'll come. And I'll tell you, I have an HTC Vive. I run it off an NVIDIA 1070 card with 4 gig of graphics RAM. That particular card has 1920 CUDA cores or cores on it. People say, well, what's the big difference? What's the big deal with a GPU? Well, a GPU has just got a whole bunch of CPUs on it. And sometimes the GPU actually costs more than the computer itself. And it's because there's just a lot of processors. They tend to generate a lot of heat, so they have big heat sinks on them to pull the heat away from them. They're little like microcomputers that are really just designed to do one thing well, which is to process video.
And as a video editor myself and now getting into VR, I love my GTX 1080. Makes a huge difference.
I tell you, there's something that's weird with them, though. I see some of them that are capping out at 11 gig, and I'm like, why just not 12? Because I like even numbers.
Yeah, I don't know either. I like even numbers too. I'm the person that when I'm getting gas, I have to end it at 0 or at 50. I have to. It's a problem, I know. So let's talk about haptic feedback to really feel like you're grabbing a gun or you're shooting. How do we as developers implement that?
It's a great question. It's a little bit of a harder one for me to answer because I'm not necessarily a programmer. I specialize in making cameras that create content, and then how people bring that content to life really rely on some other systems, whether it's Unity or Unreal Engine or however they're going to program it. That being said, I do work with a lot of directors and filmmakers and videographers, whoever, who are considering exactly this, which is how do I add haptic feedback to my story? And here's what I hear works best is generally if you tie the haptic activity with your audio track. So that if you get a punch or a kick or a recoil or, right, there is also a sound trigger that's tied with the vibration or the impact. And it's the audio and tactile feeling that actually makes that seem believable. That a vibration in and of itself may just feel like an annoying vibration. But when you combine a visual with a sound effect with a vibration, now you've delivered on the emotional trifecta that makes it believable.
So from a storytelling perspective, how different is it to do VR versus all other mediums?
It's incredibly different. And not just because you no longer have frame boundaries, you have the entire frame, but you can decide, let's say, for example, I want to do a third-person perspective and I want to watch the activity that's going on. In fact, I'll step you through a scenario that was done with an award-winning film that we just produced called Confucius. And in Confucius, you start out as a third-person observer, and you're watching this guy come in, and he sits down, not to give too much away, but he takes glasses out of a box, and he puts on the glasses. And when he puts on the glasses, you actually shift to a first-person perspective. So you actually become that character. And when you become that character, the story then has to unfold around him as the center. Now, in the case of Confucius, the filmmaker decided not to use all 360 degrees. So what he did was he mounted the camera directly in front of his face, the primary actor, so that you always saw the actor's field of view and point of view in 360-degree 3D with first-order ambisonic audio. If you were to turn around, instead of staring right at his eyeballs, which is what you would have seen, what he did was he digitally encoded in a brain back there. So that if you turn around and look behind you, you actually kind of see your brain. This is the tool that he used, that when you put on the glasses, you've been transformed into a digital world and you've become a character within the movie. It's how you ladder all of those things together to deliver the story. So it's very, very different than traditional filmmaking. But the role of the director, a lot of people think, oh, the role of the director goes away. No. You're not getting out of it that easy. The role of the director actually becomes much, much more important,
right?
Because they have to try to direct and orchestrate and manage a much, much, much larger dynamic environment.
Exactly. And how do you bring the point of interest to that person if they decided to look up, right? And you want them to look down to the right and they're looking up to the left. How do you bring them back? Which actually goes to my next question, which is about ambisonic audio and 360 audio. Can you explain a little bit more about that? What are the types of spatial audios we have today?
Let's start with what the VUZE camera does, right? So the VUZE camera has 4 directional microphones on it that creates, in our case, a horizontal field of 360-degree audio. We do capture some of the up and some of the down as well, but I'll be honest with you and tell you, we could do a better job of capturing straight up and straight down, and it's something that we're working on for future products. That being said, people often ask me, what is first-order ambisonics? And think about taking audio and pinning it to the outside of the sphere. It's kind of like going to a planetarium. In planetariums, they actually put the speakers behind the mesh in the ceiling. So you can tell where the audio is coming from, but you can't necessarily tell how far away it is. So that's what first order ambisonics does. It gives you the ability to hear directionally where the sound's coming from, but not necessarily how far away it is. That being said, with the VUZE camera, we also include a license. It gives you 90 days for free, and then you can buy an additional license directly from a company called VUZE. And VUZE allows you to take the ambisonic audio and then turn it into a 3D scripted VR audio field by putting, for example, a mono track. So you could go to your Foley studio and record a bike driving down the path and you hear the gravel underneath the tires. You could script that audio track into the audio sphere so that you can have that sound move around your subject. But in that case, you can judge and get a sense of distance because you're actually adding that path in one by one as opposed to just capturing everything around you. So in that case, kind of crosses the boundary from first order ambisonics into the VR audio, which then also requires some additional either application or something to play it back on, because that type of an audio track isn't going to pass through on something like YouTube or Facebook.
Right. Although I think YouTube does a little ambisonic, no?
They do a little bit of ambisonic, but they don't necessarily do 3D audio.
Got it.
Putting in those other tracks, you really need to start to use some sort of a programming language in order to play it back. It's almost like if you think of, this may be a bad comparison, I just thought about it, but it's a little bit about thinking audio as 6 degrees of freedom for audio. If you think about that in video, you can't really stream that over the internet today.
Right.
Kind of the similar challenge happens in audio as well. It does require some sort of a player in order to take advantage of that audio.
Right. And as a creator, shooting 2D video, and we're not even talking about creating a virtual world, but just shooting 2D video and placing mics and hiding them is a challenge. Imagine now 360 video, 3D, with multiple mics stored everywhere and hidden so they're not part of the frame, or hiding them later in post-production, which is another mess we don't even want to touch right now.
Yeah.
Right? I mean, that tells you what you're in for.
Yeah, it is a challenge. There's no doubt about it.
To create virtual worlds, we're not talking about video now. Now we're talking about creating these virtual worlds. There's a couple of what they call game engines, right? Can you touch a little bit upon that?
So the two that I know of are Unreal and Unity. So these are both programming languages that really were born out of the idea of creating digitally created worlds that you can interact with and you can make decision points, and whether it be a game or whether it be education or training or what have you. But that technology started entirely as computer-generated worlds. What's been happening lately is that both of them now enable you to import photospheres or VR video into their platform and basically use it as a background. So when I was out at VRLA, Unity was there taking in VR video, and then they digitally added in. So the video was a mountain stream roll, just the water moving down. The camera was stationary, and there was this stream going down in this VR video. So they built on the bank of the river a cabin that was digitally produced and put in there. And then there was a canoe going down the stream. So now you've taken and enhanced VR video using what was a game engine, right? So using Unity in this case, in order to make it kind of fast track, if you will, the development process, which I think is something that people don't put enough thought into, which is I could either sit down and create an entire world in VR, and I don't know how long that's going to take me, or I could go capture content out of the real world and put it into my VR environment. So I was working with a guy who wanted to reproduce a 7-Eleven convenience store. And what he ended up doing was going in and simply shooting VR video content inside the store. And originally he did it just kind of as FPO or for placement only to ensure that he could build the rest of his world into that convenience store the way that he wanted. But what he found out was that by using VR video as his base, he could do everything that he wanted to do on that base without having to go in and program and create all of the little elements that are in the store, right? All of the shelves, all of the product that's on the shelves, the lighting, all that. He didn't have to go back and recreate it. He just used the VR video as the base of his experience.
Right. And it's much cheaper to do as well.
That's right. It's much faster and much cheaper. So again, going back to the VUZE camera, which is what I'm quite proud of, is our product allows you to capture 2 4K videos in parallel. So you can make very, very high resolution content, but we can stitch that content in the VUZE VR Studio software at the rate of about 1 minute of stitch for every 1 minute of video.
So real time.
Yeah, it's basically 1-to-1.
Yeah. Now, the reality is the amount of data we are generating. We're basically looking at 8K per minute, right?
Yeah.
That's a lot of hard drive space. You need a lot of data, a lot of backup solutions, and you need also a somewhat powerful computer to work comfortably when you're editing, not just with your camera, but just any camera.
All of them. Yeah.
So that's something that we as creators have to be aware of, that, yeah, let's shoot 30 minutes of this kind of video, but do you have the infrastructure to support that?
There's a couple pieces to it. So first of all, we've seen the people who have been most successful in this category right now are people who already have experience or infrastructure to manage 4K video. Because if you're used to dealing with 4K video, then VR video isn't going to scare you, right? Because you're relatively familiar with overall file sizes and what have you. But yeah, I mean, the files can add up because you're really going to end up dealing with ultimately 3 separate files at the end of the day. So if you're a shooter, in fact, in my workflow, I get 4. I can tell you about that in a minute. But basically, you have the raw data from the camera itself. And that creates at about 1 gigabyte of data for every 1 minute of recording. Now, to me, that's my digital negative, for the lack of a better term, my master, and I'm never going to throw that away. I'm going to keep it. I then decide and I render out my video of that I want to capture and I want to use. I always output it at about 120 megabit per second rate from our camera. So that creates me another file that's about somewhere between 500 and 600 megabytes per minute of video that I'm recording. Then I take that and I put it into, I'm an Adobe Premiere guy. I'll edit multiple pieces together to do a final linear piece. And that's going to turn out to be, say, another 500 megabytes per minute. So when it's all said and done, you're going to generate about 2 gig of data for every 1 minute of recording on a fairly regular basis.
And in a 30-minute movie, you're actually recording probably at least an hour.
Yeah,
so
exactly.
Do the math. I can't do the math because my brain is going to explode now, but we all get it.
You know, you're 120 gig if you go out and shoot for a day just to get started.
Yep. Right. Exactly. So it's something that we as creators have to be aware of. And it's almost bringing us back to the film days where you're more careful at what you shoot and you plan out a lot more than just say, let's just turn it on because it's digital and it doesn't matter, because it kind of does matter. And even if we have all that space to store it and back it up and move it through the pipe, is do you want that much data to have to go through? Because there's a lot of stuff here.
Well, I'll give you my trick real quick. And so if you end up shooting with the VUZE camera, feel free to do this as you please. So here's what I do. I take all of my video, and let's just say I shoot an hour worth of video. The first thing that I do is I render it into a 2D file, so not 3D, but just a 2D file at HD resolution. I have no intention whatsoever to play this in a VR headset, so I don't care that it's lower resolution. That file I then take and I put into Premiere Pro, and then I cut the video how I want it. Then I have a nice big size preview. I can easily see what's going on in the frame. It's easy for me to do my cuts. I get everything basically the way that I want it. Then when I'm ready to actually render my final video, I go back to my actual masters and I mark my in and out points of where I want to start and stop my video. I'll output it at the maximum resolution that I want, and I'll create a new file. And then I will simply swap out the files in Premiere Pro, the low res to the high res files.
So you're basically using proxies.
Exactly. But by making that initial file low resolution and only 2D, it's very easy for me to see what's going on the screen. Sometimes when you start looking at 3D footage, so you have left, right eye, top, bottom, right, file format, equirectangular, or worse yet, cube map, sometimes it's hard to see exactly what's going on that screen.
Yeah, that makes sense. So currently we have 4 major HMDs, head-mounted displays, right? We have the Rift, the Vive, the PlayStation VR, and the Samsung Gear VR. There's a whole bunch of others too, but those are the 4 major ones. The question that I have to you, and this is where I see an issue with the industry right now, is that everybody has their API, their application programming interface that you can code to. So there are games today, and I believe Doom is one of them, that only works on the Vive but doesn't work properly on the Rift. This is part of the problem. If we go back to the adoption, we started with that question way at the beginning of this conversation, is how do we get people to adopt it? I think that is a big problem, and that's where people are not going to adopt it, because it's kind of like saying, well, let me go to Amazon.com, but you have to use this browser.
Yeah.
So what do we do?
Yeah, it's a tough one. Let me first talk about what we do. We create an open industry file format in H.264, and we're trying to encode to as many different file formats. So if you want to follow YouTube's recommendation of 2:1 aspect ratio H.264 MPEG-4 files, no problem, we can do that. If you're cutting edge and want to start to output for Facebook Cube Maps file format in 4K per eye, hey, we can do that too. So if you want to output at 3072 by 4096 for left and right eye cube maps, no problem. That's what we're doing. The battle of compatibility comes down to who wants to try to own the ecosystem or the currency of VR. The reason these proprietary file formats exist and connectivity is so that they can kind of own the value chain. I think, this is just my opinion, that VR is too big to be owned by a single company. That VR should be treated as an open platform, much like the internet, and that everybody should figure out a way to be cross-platform and then let people compete based on the services you provide, which one of those headsets that you want to be able to buy. But I also live in a fantasy land that may never come, because the dollars and cents are what's driving it on the back end.
I agree with you 100%. You want like a W3C for VR, basically.
Yeah.
And I'm sure Facebook with the Oculus and HTC with the Vive and all of the future companies, they're going to have to figure out a better way to make money than just with the HMD. But I know people compare an HMD to like an Xbox or a Sony PlayStation, right? They try to make games that are only for that.
Yeah.
But like you said, I think VR is much bigger than that.
It absolutely is, especially when you start thinking about commerce opportunities. Today, we have all struggled with putting together IKEA furniture. Sometimes I hear people say, well, boy, if I could just watch in VR how to put together my IKEA furniture. Okay, great. I think that's a good, viable tool. What they haven't thought yet is, wow, you mean I could actually go shopping at IKEA for my put together furniture. And I can experience how hard it is or how easy it is to put together. I can visualize it in my living room. I can determine the size. I can figure out if in its package it's going to actually fit up my stairwell to my apartment. Like, the power of VR, it's not just a playback and view tool. It is a commerce, interactive, emotional tool. And when, as a creator, right, if I'm a creator, somebody in the future is going to have to photograph every single product in the world based on UPC, so that somehow, as if by magic, I can scan a UPC code and put that product into a VR experience. And whether I'm going to Amazon to view that, or I'm going to IKEA, or I'm going to wherever it is, like, the infrastructure and the possibilities of virtual reality and activation of all of this content is huge. And it's not realistic to think that all of that content is going to be computer generated content. It's going to be photographed, real world, and modeled into a digital representation. It's a really cool thing. I think that open platforms are huge. And I will tell you that somebody who's been playing in this stuff pretty in depth for the last couple of years, if you were to ask me today how to watch a YouTube video in an Oculus headset, I would have to pause and think, or maybe even phone a friend, because it still changes regularly. And without knowing the platform or the menu structure or the something, it's hard to figure out. I agree, but that's just a temporary problem.
I 100% agree. They just released I'm sure you play with this already, the Oculus Rift 2.0 core, which now you can do a lot more without taking your headset off. You have desktop, you can pull out apps from your desktop and place them anywhere in the VR sphere and work with them. I wouldn't say as easy as you do today with your regular 2D computer. I don't know. Should we say that? 2D computer? I don't know. But
you know those old things called computers we used to use?
Exactly.
Yeah, those things.
But you can definitely, I prior to the 2.0 core upgrade, I had to take off the headset and then go and pull out my email if I wanted. Now I can literally, I have my desktop, I have it all in my headset, and I don't have to move away from it. I can even type it. We have a virtual keyboard. It's not great yet, but it's getting there.
I've been doing it for about a year now. So with my Vive, when we first started testing our color spectrum for our camera, I was making videos and then I was transferring them over and I was putting them in the headset to see what they look like. And this light bulb came off to me and I said, well, why don't I just do it in VR? So I put a virtual desktop app on my PC and have my HTC Vive, and I opened up Adobe Premiere Pro and opened up color correction. And I started actually doing color correction in my headset. So I can enlarge my virtual desktop as large as I want. So I have the part that I'm color correcting fill my field of view, and I pull my sliders and I adjust the color for my headset. And I do it in my headset. And when I first started doing this, I did it. And then all of a sudden I got this alert that I had a message that came in my mail. And I'm like, oh, wait a minute. So I clicked on my mail. And then I could actually respond in my mail in order, while I was in the headset. And believe it or not, once you do that for a few days, you start realizing, hey, I just spent 3 hours, 4 hours, 5 hours in a headset.
Yep.
And it's the most productive time you've ever had. My only frustration in that is in my scenario, I have no way to see my keyboard. Now, luckily, I'm a pretty good touch typer, but I am constantly reaching out, trying to find the little bumps on the F and the J so I know how to get started.
Right.
But once I do that, I can do a pretty good job.
Well, with the Oculus Rift Core, you have a virtual keyboard that pops up and you can type with your hands. Literally, you point with your fingers. Now, it's not as great as typing in a real keyboard, and it kind of messes up sometimes because when you're pointing, you touch the wrong key. But again, this is today. It's not what's going to be like in 5 years. So I think people, especially creators today, we have to be evangelists and explain to people not what we have today, but the possibilities of tomorrow. And I think that's the key for adoption, is telling people and explaining to people, letting them see what we have today, but telling them, think of 5 years from now. Think of where we were 10 years ago with the internet and with computers and where we are today. Well, think 10 years from now for VR. It's going to blow our mind away. One final question, because we're all about e-learning in this podcast and bringing filmmaking techniques and VR techniques now. So we make e-learning better. Do you have any thoughts on VR, 360 video, and specifically e-learning?
Great question. Here's what I know as it relates to education in general. Originally, when we first started shipping the product and having conversations, we started getting calls from a lot of teachers and academics that were out there saying, hey, I want to be able to teach this class. I want to be able to share this experience. I want to be able to demonstrate this concept. And there's been a pretty sharp adoption in that. So creating learning content where you can step somebody through and build different narratives and sub-narratives where they're delivered a different outcome, right? Maybe a right or wrong answer, and then the learning on the back end to correct for their mistake. The other part that's become more important right now is the number of learning institutions, schools, universities, all the way down into elementary schools, who are purchasing the VUZE camera to teach VR in their curriculum. They realize that to teach the principles of virtual reality in computer programming, not all kids or young adults are programmers, and they may not ever really learn how to program code. But they are visually stimulated creators who want to be able to share the world around them, who want to be able to tell stories, and they have incredibly powerful minds. And what virtual reality allows you to do when you capture the real world is to be able to tell that story and to educate and to train. So I don't know how any of that replies entirely to e-learning, other than to say that, really look at what you're teaching as well as those who are teaching others and how they're teaching others the principles.
From my perspective, I think e-learning is going to be a huge industry for virtual reality. There's an amazing amount of information that you can tell in the virtual world that it's much harder to tell in a 2D world. And having that immersion and the ability to experience something you're trying to teach, I think people will attach themselves much quicker and learn quicker than in a book or even a 2D tutorial, let's say.
Absolutely. I was at, I think it was UCLA. I think it was one of the California schools. I'm sorry, I've been to so many different conferences. I forget exactly who it was that presented it, but they were talking about statistics and data visualization in a headset. And the demo that they had was that you could put on a VR headset and you actually walk into the data set of numbers or barcodes or cone graphs or whatever it was. It's a combination of everything. But then you actually start to see the representation and scale between the numbers, and you're walking around the data and you really start to see all of these insights that you probably would never see on a spreadsheet or a 2D graph. But we can actually go in and you can start to see holes in the ground, which are your losses, and these pillars coming up, which are your gains. And then you can look at them and it's amazing.
Gives you a different perspective.
Absolutely. And everybody's brain thinks differently, right? Left brain, right brain thinking. And right. So how one person may interpret that data may be entirely different than somebody else. Using things like heat mapping and watching where and how people interact with that data in and of itself is creating a huge amount of data.
That's a topic for like a total dedicated podcast, but it's collecting data in virtual reality for analyzing, for either adjusting and changing that virtual reality experience on the fly as they're experiencing it, or for later figuring things out. What did they like? What did they not like? What did they interact with? And from an e-learning perspective, we have an X API, which I'm not an expert at all on that, but I know you have the ability to collect a variety of data. But again, that's like for a much longer podcast, which I know you're going to have to go home and eat and go to sleep too. So Jim, I really do want to thank you for doing this. I mean, this was started as a 20 to 25 minute conversation that we went, I think, of about an hour and a half.
I think so.
I really thank you for being so patient with me and for answering every question. You were great.
No problem. I love this stuff. I will always offer myself up to your listeners. You can reach out to me. I do my best to answer people when they do reach out, because we still are at this level of cooperation right now where we have to cooperate as an industry to make the business. Then we can go fight it out as competitors later on.
And tell them your website address, and then also give them your email, and I'll still put it in the show notes.
Sure. So the easiest way to get to our product website is to go to VUZE.camera. So it's VUZE.camera. You don't need a .com on the end of that. Just VUZE.camera will get you to us. And then if you want to reach me directly, I'm jim@humaneyes.com.
Excellent. Well, thanks again, Jim. And to the rest of you, I'm glad you were here with me. And remember to subscribe and leave a review. So until the next episode, I'm your host, Marcelo Lewin. Cheers, everyone.